my name is JP, here to talk about Recollect Energy. So here's kind of the big problem. This is a crazy slide, but I want to outline two things on it. This is a flow of all of the energy consumed in the United States in a given year. And so if you look at this, you see all of the sources and all of the uses. It's complex, but the only two things we really need to know are one, that at the end of all of the generation, the usage, this 60% block is rejected energy, energy that's just lost. The vast majority of that is wasted heat. And so this is energy that's produced, consumed, and this is the remainder. That's 60% of the entire country. If you look at the different sectors, you see that transportation is the least efficient. And so here, 80% of the energy consumed by the transportation sector is lost as waste heat. One of those reasons is because combustion engines are just limited in their efficiency. The very best case scenario for an engine is about 35%, and the rest of that is lost as waste heat either through the exhaust or through the radiator. Heavy trucks, like you see here, Class 8 18-wheelers that drive cross-country day in and day out, account for only 6% of vehicle miles nationwide, but consume 17% of the fuel used on the road and account for 30% of the emissions. So they are less efficient than the average, and they are significantly dirtier than the average vehicle. Because of this, you see a lot of regulatory pressure in the latest EPA and NHTSA, the Traffic Safety Administration regulations, require these trucks to become 40% more efficient over the next decade. We have a solution to this problem. It's called thermoelectrics. And so this is not a new area of technology. Thermoelectrics are a solid-state device that convert wasted heat into usable electricity. They're powered by nanomaterials, and they're modular, so you can start at a very small scale, 20 watts like you see here, and you can scale that up to any given power output. What we do that's special and compared to everything else that's out there on the market is we have patent-protected IP that reduces the electrical resistance within one of these modules, and that's basically just a way of saying we make it more efficient because less electricity is lost to little areas here and there. We reduce the resistance of the contact layer, so you have a hot side and a cold side. In the middle there are several things sandwiched. And where those things make contact with each other, we've reduced the resistance of electrical and thermal resistance by 20 times anything else that exists. So you take that solution and you apply it to any technology out there that is thermoelectric based, and you see a huge efficiency leap. That's about a 40% efficiency gain if you were to apply our solution just on the contact to industry-leading solutions right now. We also have patent pending as class of materials and manufacturing method for the nanomaterial itself, which is a class-leading scudderidite material, which is just to say that its operating range is between 350 and 600 degrees Celsius. So now, how do we make money off of this? We manufacture these modules and work with customers to integrate them into the systems that they make. And so for things like those heavy trucks that we talked about, we can incorporate these into systems and improve system efficiency. We can also sell the modules. There's a market today, it's a $100 million market just for the modules on lesser technology that's already out on the market. We can expand just the module market with our new developments. So in order to break into this market, because we add efficiency in ways that have never been done before, we first want to start by developing an aftermarket system for trucks. So we can take this directly to market, get customer feedback without going through all of the industry hurdles that are normally associated with that. So here we've christened it the TR1, which is just short for truck version 1. It's a 75 module device that harvests heat from the exhaust of a truck and uses that electricity to run back into the system. So you see here, really basic, you have the engine, you have the exhaust. The alternator is turned by the engine and powers the truck's electrical system. What we can do is now create a new source of electricity from the exhaust, disengage that alternator, and by disengaging that alternator, we reduce load on the engine and improve fuel efficiency by 5%. Roughly, the only thing a truck fleet manager cares about is the payback period. So if you look at today's prices, this is actually probably from Monday. Diesel price nationwide average is $2.40 a gallon. It was less. It's getting better. Projections of $3 a gallon by 2018 when we hit market. means that this pays for itself in 1.6 years today, or less than a year and a half in at the time of release, based on current models. And so this the year and a half, the 18-month mark for truck fleets and manufacturers is kind of the magic payback period that we've heard again and again and again with interviews with all of the major truck manufacturers, with several major fleets. So we're able to hit that and do better. The market size here, I know I'm over time, Jay, because this is kind of a longer pitch than usual, but I will try to keep it quick. Just in the 18-wheeler market, so excluding all of the other thermal electric markets that exist right now, you see the potential for $1.3 billion of waste heat recovery technology on the 18-wheeler trucks that are sold in the United States today. There's a really great study done. It's a survey of all the major fleets, and you see adoption of similar technologies, not quite as good as ours, at a rate of about 14%. And so that's our served addressable market today. That's $182 million. We think, based on our projections, that we can hit about 10% of that, or only 4,500 trucks out of the several million on the road, that we'll be able to hit that within 5 years. This means not only cost savings for the customer, but also a huge amount of carbon emissions reduced. So if you look over the lifetime of a truck by 2020 with our current sales projections, we reduce carbon emissions by 18,000 pounds per truck, or 81 million pounds of carbon emissions reduced by 2020, and these things last the life of the truck, so that just accumulates over time. Right now, where we are, we're still very early stage, so in a module, you scale them based on sort of pairs of thermoelectric ingots, if you will. Right now, we have a very little one. It's just one of each type. Doesn't make any significant electrical output, but we see the data results from that are really significant. And what we need money to do right now is make a full module. This will be something that is a product that we can take to market, and we just need to validate what we think is already true. So that's what we're raising money now for. In terms of timeline, that puts us, these module processes are the main focus right now. We need lab space, we need some engineers to develop these and to be able to test them at independent facilities. After that point, we begin selling these modules on the market that exists. We also develop our truck solution. We start bench testing that. There's an awesome truck efficiency testing center at the University of Houston where we're based out of. So we already have that deal set. We just need something to test. And then down the road in the future, mid-2019, 2020, we'll be able to sell those truck systems to aftermarket fleet owners and dealerships that want to provide better fuel efficiency solutions for their customers. So we're looking for about $300,000 in seed capital, coming from sources such as a few different grants. We're working on the I-Corp program at a national level, which is an NSF program for some really intense customer discovery. And then the key part here being strategic and angel investors as well, so that we don't have just money that's bound by grants, which is part. $300,000 will get us to the point where we've validated this project. We have larger scale prototypes. We're able to bring them to customers that would buy thousands of them and say, here's one, here's 10, here's 100, test these out, see how it works for you. And at that point, we'll have the product and market validation that we need to raise a Series A and begin manufacturing. And so again, that goes towards lab space, modules, market validation, and then a team of engineers once we're developing the actual truck system. Our team, this is me, I'm JP, Laura, and Dr. G. All three of us are from the University of Houston. Laura and I went through the entrepreneurship program there. We're both finishing up our undergrads in December. Dr. G is a materials science researcher, has been in thermoelectrics for over a decade. He is the inventor of the technology and is a co-founder of the company, and is the one that's leading our R&D. We have some pretty cool advisors. Dr. Wren is the lead inventor that oversees the research group at the University of Houston, has a long history of research at Boston College, at MIT. We have some really good jobs there. We also have some cool people like Scott Perezinski, who's a retired astronaut, climbs Mount Everest, and just launched a seed stage VC fund for energy harvesting systems. So we're working with him to secure investment down the road, and he's sort of mentoring us on the interim. John Grossman runs a company that does a lot of tech transfer. Hector Chagoya is an IP attorney. Jeff Spitzner is an account executive at a major supplier to the automotive industry in the heavy truck space. So this is our path to market right now. Our future applications are not just for trucks, but things like the military, refineries, trains, even jet engines are all places where there's a lot of waste heat that can be harvested. That's my pitch. My name is JP. Thank you. Questions, comments, concerns?
When do you guys do this?
Free
Throw it at
form.
'em or what?
Freeform, let's do it.
Okay. I love the brand, the name, the logo. It's really good. That's great. Usually it's nasty. Um, I think I don't understand how it reduces emissions for trucks. I guess because the engine's more efficient, so it burns less fuel per mile. Is that why?
If you improve the efficiency, then you burn less fuel.
Okay.
Yeah.
So that's fine.
We
So
don't
you set
screw
up
up
the EPA
emissions.
as a potential problem, but not in the solution. So the solution was about a payback period in terms of fuel costs, which makes total sense, and I really like that. But you didn't solve the EPA. So are they going to have to solve this EPA thing, and you're a fundamental piece of that? Because if so, that's on top of the ROA argument. So if that is true on the solution side, you've set up like problem EPA, solution EPA, you're halfway there or whatever, right? And so if it doesn't really help that much to get to the 40%, then maybe that's not terribly interesting. Like if it's 5% out of 40, like they're going to have a lot of stuff to do. Like that's not really the problem. Then it's fuel savings,
And
right?
that's the case. Yeah.
So one of the other side of that, either get it out of there or pay it off, right? Because you set it up and then you didn't pay it off. When you're telling the story, you set it up as a truck thing, which is great because everyone can relate to that. And then you got into all the tech, and then later back to the truck. But the setup and payoff is like trucks, suck, and it's huge. And guess what? We can kill the truck. Like and the payback period is something that everyone loves. That's it. It's like problem solution. Bang. Then you can say, but wait, there's more. It's not just trucking. See, the thing that's in that thing, it's nothing about trucks. There's these little modules that we can resell for anything. You can put it in a train, you can put it in it, right? And then you can get into, in fact, what we've done is brought it down to this little ingot that you can then put in. So in other words, you could build this, rather than going set up the problem, wait while I tell you all the little details, which are not really relevant. I mean, they are to the final solution, but the point is we solved it, and here are the results and the payback period. So if you move that up here, you can set up, nail it, and then and there's all these other places we could take it after that. Because after that's not even in 5 years, so why are we even talking about it, right? And except at the end as future of how you can
take notes.
Yes.
I really like the payback though, especially because you know the customers like that payback. That's good. And then the final thing is the timeline just seems so protracted. Like $300K to get you for another year and a half or a year, like that doesn't seem like enough money to do that unless almost no one's working on it. And so it seems like what would be better is to have that $300K only last you 6 months and have more people working on it and get done already. Get it out there. This timeline is way too long.
Thank you. That makes a lot of sense.
So a couple things build on what Jason said, but let me just ask you a question, personal question. Did you have a technical background?
I'm sorry?
You're an engineer? What's your background?
My background is business.
Business, very interesting. Because usually engineers, when they talk about technologies, they'll really dive deep into the technology. And Jason kind of alluded to that I think you're going to have to make up some time. And I think that whole section about the technology and how it works and how there's a lot of complication on the slides, and we're getting up there in front of the crowd in Google Fiber, the crowd's really not going to be able to understand the details of those slides. And if you have to turn around, start using a laser pointer, they're just not going to follow it. There's going to be people talking in the back, even though we tell them not to. So, really just building on what Jason said, that really, I would just de-emphasize, you could say basically, we've developed a technology that passively extracts energy from heat. And that really is the entire flow. And then you can say, and we're different because our competitors have this efficiency, we have this efficiency, this is how it changes the payback period. It's very, very tight. You know what I mean? And so that's the slide with that, with the modules in the beginning. There's another slide before that I actually had no idea what that was, but you're about the market or something. But if you want to look at that one too, I don't have any comments on it. But and then later on, I think you talked about. I know this is just a practice pitch. You go refine the words. But we you talked about going from a little teeny module to the gigantic compilation of modules. You said, right now right now it's not really producing a lot of electricity, and then we want to scale this thing. So it kind of, in my mind, meant that you're raising money to just demonstrate that the technology even works. And I think there you probably just want to say, we have technology demonstrated at the single module level, and this effort will be to bring that to scale that can be used in a production environment. But if you haven't demonstrated that it even works, that's a much bigger problem, I think, than and that. And I said, if you're not there, if that's not the case, then you probably don't want to be alluding to that.
I like that second slide that had all the pathways, but it is true that when you're up in front of the audience, number one, people won't be able to see. I mean, I'm in the front, I can read it, but most people won't. It's an eye chart, right? You can't read it, and they won't see your laser pointer. And also, it's kind of bright in Google Fi, where you're not going to see a laser little red dot. So what I would do, and this is a nitpick, but I would make a build in there. In other words, next, and then put it in there that you've highlighted, put a box around it or something, and put arrows so that you can just not use your pointer, but build so that people in the back can see the siphon where most of the siphon is waste. Like that's clear if you outlined it. That has a nitpick, but that would solve your display problem.
Absolutely.
It's a cool chart. It's really interesting.
But it's complex for a projector in front of everybody.
Well, I mean, it's easy enough to say, look,
Reducing it down.
where energy comes from and goes across all of America, obviously is complicated. So there's pipes going everywhere. Here's the thing to notice: look how much waste there is. And furthermore, transportation, it's mostly waste. Holy moly! That's it, right?
I think by doing that, this off my comments in that as well, but it really gets into the style of presentation, and that is you want to be engaging with the eyes of the audience, and when you have something that you are required to turn around, first of all, you should never talk while you're turning around, but if you do need to turn around, it does detract from the audience. So you want to be upfront, looking at people, and you practice that probably 50 different times with that clicker, and I'm not sure what the backup plan is. Like if you were clicking it, but you actually didn't click the box, and maybe you have somebody in the audience who can tell you that if you had it right. But always, like I said, the eyes on the audience is always good.
All right. Who wants to go next?
Thanks, JP.
Yeah, it's great.